Hello, I'm Gabe Filippelli, and I'm so happy to be with you today. I wish I was there live, but hopefully this presentation will stimulate some ideas and discussion points for your group moving forward. I'm going to be talking largely about the intersection between environmental sciences, environmental justice, and community engagement. And in that context, I hope you take away from it at least a number of ideas about how you could develop partnerships with communities to forward both of your interests, both the university researcher interest as well as a community well-being interest. Of course, there's no one way to do any of this stuff, right? And it's very context specific and place specific. But I'll just show you at least a little bit of the thinking behind how I've engaged with communities, what I've learned, as well as a little bit of a push or a nudge toward institutions to adjust the way that they do business to better accommodate these kinds of interactions. I'm the executive director of the Environmental Resilience Institute at Indiana University, but I'm also a professor at Indiana University, Purdue University, Indianapolis, IUPUI, this strange acronym university that is in itself a partnership between two university systems. And what I found, this is sort of an overview of what I'll be presenting, as well as some of the ongoing challenges, is that I hope to present to you at least some vision of successes at mapping the distribution of contaminants and creating some kind of transformational science from that. So hopefully, at least in my opinion, new novel discoveries. And also the successes we've had with engaging citizens, well, we call them people, but there's, for better or worse, there's a term citizen science that has been dominant in the field. But engaging citizen scientists and also training youth, the next group of environmental justice warriors. Also, we'll paint a picture that shows that there's a number of challenges that face these kinds of efforts, like there is with any effort. But the challenges are, as with most, are unique. There are funding challenges. How do you get cutting edge environmental science funded while still keeping an eye toward environmental justice issues? There's challenges of interdisciplinary training and breaking down academic silos. There's challenges of balancing professional priorities. And there's also challenges inherent to publishing actually citizen science. So using samples not actually collected by you, the researcher, and publishing them in the literature. I'm going to do all of this through one particular lens, and it's the lens of lead poisoning. Why do I do that? Well, lead poisoning still impacts over 500,000 American youth every single day, and it impacts millions globally. Lead poisoning literally costs minds. This is a great visual portrayal of what lead poisoning does in the human brain. These are brain scans of response, about brain response and speed of response from a cohort of now young adults who were exposed to lead when they were infants. So they were part of something called the Cincinnati Lead Study. And these kids were demonstrably lead poisoned as infants. And I'm going to show you a lot of cases of other people, unfortunately, were lead poisoned. And then they were continually followed for decades. And this is after a couple decades doing brain scans, functional brain scans. And you'll show, obviously, the obvious thing is there's big areas of the brain lit up in these bright colors. Why don't you focus particularly on this side view cutout of a brain? These were not, they didn't cut anyone's brains out. These were MRI scans. But these are, everything in color is a neural deficit. So this is an area where neural density is especially low compared to a control population. And these neural deficits are all in the area that we consider being our uniquely human part of our brain. It's the brain, it houses our executive functions. So memory, intelligence, impulse control, all factors that really do have helped us become the organism that reigns the planet as we are. But you can see that when these kids are poisoned at youth, it severely impacts the development and the density of neurons in those parts of the brain, and it never recovers. So this figure shows a couple things. One is that profound difference in functioning. The second is these were done 20 years after these kids were lead poisoned, and it still remains. So lead poisoning is permanent. There's a lot of evidence that indicates that it actually gets worse as you get older. At least the cascade effects of lead poisoning get worse as you get older. And it is a condition that should be easily treated because we know the sources. First, we know how it gets into the body, and this is why kids are especially susceptible. Their intestinal systems are less selective than ours are as adults. And so they absorb, for any given amount of lead they might ingest, they absorb something like 80% of it, depending on the child's age. We only absorb about 5%. They also have their behavior. You've seen kids, they're very low to the ground, they're very short individuals, and they stick a lot of things into their mouth as a way of exploring. So they actually ingest a tremendous amount of lead in dust and soil and so forth. And so they not only ingest a lot, they absorb a lot of that they ingest. And finally, this is the worst part, is that their brains are actively developing neurons. As you're all sitting here, we're largely just losing our neurons day by day. Well, kids are in that process of, for one time only in their life, forming those neurons. So you can see why it's such a dangerous kid disease. It doesn't go away just with youth. If you take a lead poisoned kid away from the sources of lead, a lot of that lead will still be in their body, and it'll still continue affecting their health. It's because about 90% of the lead that comes in and shows up in the blood ends up being sequestered in bones, where slowly leaked out over the lifespan of a bone. We know very well what happens in the body. We also know where pretty much all this lead came from, which is from our profligate use of this metal for particularly the last 100 years or so. We found that, hey, it works great in paint. It makes a very durable and flexible paint. So we use a bunch of lead in paint. A lot of house paints, some house paints especially, were high, but a lot of them had lead concentrations to 5-10% by weight lead. Second, we came up with a brilliant idea to stick it in gasoline as an anti-knock agent, where it spent then decades being emitted out of tailpipes. And we also put it, of course, in lead pipes in cities. So all of those sources, we've shut them off as we realize how dangerous lead is. But the problem is that didn't necessarily clean up the problem, right? Lead was distributed around the world, particularly in areas where you might have a lot of housing stock and a lot of vehicle flow, or in other words, cities. Where most of that lead just resides in the surface soil. In fact, lead's not even very mobile. So a lot of the atmospherically deposited lead, whether it's from decayed paint or combusted gasoline, is sequestered up in that top layer of soil, where people get exposed to it over and over and over again. And so you can actually go into a city and map out make some guesses and some educated guesses about where you will find that lead. And it is, as I mentioned, in old urban cores, where they had a lot of these sources, as well as near some industrial facilities. And the real challenge here is it's in surface soils. It does not migrate downward very quickly. And so it is a situation that's not going to solve itself anytime soon. We spent a lot of time mapping the distribution of lead, in fact, in surface soils. And you could see that these characteristics are true. These urban cores having a high amount of lead, whether you're in Chicago, Illinois, Sydney, Australia, New Orleans, Indianapolis, from a lot of our own work, and even in little South Bend, Indiana, northern Indiana, tremendous amount of lead. So any old city, whether it be big or small, is going to have a significant amount of lead contamination. I'm going to return to this type of graphics toward the end of this presentation, because this is a platform we developed. I think it's of interest to you. So that lead doesn't just stay in soils, it unfortunately gets in kids where it poisons them. This is the unfortunate map of lead poisoned children in the city of Indianapolis. This is a compilation of over about 10 years of blood lead data down to the address level. And you could see that guess where the kids are being poisoned? Well, near the urban core, which is this part of the city, along major roadways, which are these roadways. And so they're being burdened in their very own communities. There's a couple of glimmers of hope, but they're actually false hope. You see this valley in here of almost no lead poisoned kids. Well, that's because no kids live there. This is the downtown. This is the IUPUI campus home. That's the government center, our couple of our big stadiums. So, unfortunately, this is a very vivid picture of current lead poisoning in the city of Indianapolis. And the sad part is if you look at maps from 20 years before this, you'll see the same spatial distribution. The general level of lead poisoning, fortunately, has gone down because we took lead out of a lot of these products, particularly gasoline, but it's still out there and it's still this lurking danger. And most public health agencies are determined, obviously, to deal with kids who are lead poisoned, but they deal with it kid by kid, and they deal with proximal cause after proximal cause. So you have a child at address A, well, they get treatment, or their house gets cleaned up, and then they're done with that case, right? They clear off the case. Well, these are communities that are being burdened decades by decades by decades. So that doesn't solve the problem for the communities. It really involves people who have an environmental viewpoint toward this issue of tracking down the hotspots and eradicating the hotspots, or providing adequate tools for communities to getting around those hotspots, so that we no longer have to use a map of lead poisoned kids like a canary in a coal mine to deal with this, but we can nip it in the bud. And I'm going to show you now, kind of through the rest of this, several of our attempts to do this by using citizen science and community science. And it all started with one particular neighborhood with high soil lead values, high lead poison values, and an opportunity to step in and make a difference. This opportunity came about from a number of community gardeners and community organizations who wanted to understand whether there's any lead hazards in their community. So we partnered with them and got a tremendous number of samples from this very small area. We also had a high school class, an AP Environmental Studies class that partnered with us, of kids who live in this area, areas of uniformly low income community. Interestingly, it's not just Indianapolis has a very large African-American community. I think it's 14% of the city. This is a mix, actually, of low-income African-American, Latinx, and white communities, kind of in little pockets through here. Uniformly, you see the same pattern, very elevated soil lead values. In this case, we took samples, often in partnership with these organizations, community organizations, and we analyzed them. Some of these, unfortunately, this one was the site of a community garden that they want to have sampled, as was this one, which is the site of a developing community garden. Nevertheless, you'll see these values by way of reference. The normal amount of lead in soils is below 50 parts per million. You can see that most of these are far, far above that. In fact, one of these areas here reflects an old Superfund site that supposedly was cleaned up 15 years ago, sorry, but clearly still shows evidences of lead contamination all around it. We actually use this data to help this community activate some action on the part of the Environmental Protection Agency here. High school students took these samples and mapped out distributions in their own neighborhoods. And I thought, this is strange, this has already been cleaned up. And to verify, they took them in again and confirmed that they were actually very high. And so it was evidence to me that the cleanup was inadequate or inept, or both. The community was going to explore options. One of the options they were asking me to do is, contact the EPA. But, I kind of, on reflection, it's really the community's voice that's the most important one right here. And since they helped collect the samples, it seemed more important that the actual people who live here were the ones who contacted the EPA, which we helped facilitate, and the EPA did re-review all of the data and came back and took some more samples. I would like to think they were doing due diligence. I think they didn't trust us, but nevertheless, they confirmed this lead issue, and they cleaned it up. Actually, so that's great. They cleaned this up. However, that does nothing to solve all of the other diffuse lead problems in the city that were from automobile exhausts or lead painted structures and so forth. So that's still the challenge that faces us as cities and communities. And to start overcoming that challenge, we realize that we need to have some ways into communities to help them get what they want. A lot of these communities actually wanted soil testing. They wanted to know whether they have a problem. And a lot of them at the same time, we're trying to develop urban gardens, whether a community group or just an individual. So we received some funding from a local foundation to provide free lead testing for anyone who wants it. Provided a lead pamphlet, a booklet that talks about sort of the do's or don'ts of urban gardening, as well as provided resources for people who wanted the testing or advice on sampling and so forth. And as part of this effort, we got something like 2,500 homes that we have samples for, and we've returned results for. And we use this initiative to then spark another one where we got to really work with some of these communities, particularly their youth leadership programs. And in this case, we got another type of grant, in this case, an internal to university grant, a fellowship. And with that fellowship, we bolstered some of the communities that already had youth leadership programs. We provided fellowships, they were called environmental justice fellowships, to them. And so there was 3 community organizations, and they got together on this group project. It was really exciting. A lot of these young minds, young people had never been at a university before, even though it's literally right across the street in one case. So we took them out to the lab and showed them what we were going to be doing. And then we had multiple sessions, workshopping sessions, where they came up with how they're going to manage this project. So they helped co-design the research project. And as a consequence, they thought, well, we don't want to just have pamphlets. We want to have active media. And so they developed a couple sampling and videos, including with Chio down here, who did an amazing job showing students how to sample. And they wanted to have other resources like a live map, which I'll get to in a little bit. They also brought some real new innovations here, strangely. These might not seem like innovations to a researcher, but they actually were. One is just a very simple thing, is that residents don't respond well, especially in an area where there's impending gentrification, to people, particularly people who don't look like them, knocking on the doors, out of the blue. There's immediate distrust. So what these youth groups asked is, well, can we print up some door hangers? We just leave a hanger on the door and say, hey, we're going to come by again tomorrow. This is what we're doing. If you're interested, this is the background for you. If not, no worries at all. Just leave the door hanger on the hanger, and we won't bother you. So that actually got a tremendously positive response. The other one took a while for me to learn about, but I had been talking in this one particular community about the need for testing daycares. Obviously makes a lot of sense, right? And licensed daycares do have to pass a lead screening test, soil test, for their playgrounds and in some of the interior structures. Well, these were unlicensed daycares. They were very valuable community resources, but they're informal daycares. Right. And so there might be 5 kids in them. These kids might be in them for a long part of the day, but they were essential fabric of the community. They provided income to the people who owned these houses, and they were, often literally 2 or 3 blocks away from the moms or dads who had their kids there. And so, I thought, wow, I'd love to have tests to make sure that these unlicensed daycares are protected. But there's a lot of reasons why they wouldn't allow this kind of testing, right? There's a reason why they're unlicensed. So the students took that and started brewing away with it. And then I talked to them about some of the very simple solutions you can create to protect kids from soil lead. And one of them is simply putting thick layers of mulch around the edge of households and in playgrounds, right? I know that sounds very simplistic, but If you cover up lead-saturated soil, lead-enriched soil with a thick layer of mulch, it immediately cuts the lead exposure for the kids who live there or play there to zero. Right? Think about it. It just seals that lead up. Does it do it permanently? No. We've all seen how kids kick up mulch, my own kids included. So it does have to be repeated. But the whole point is that you're dealing with, at least with the problem right here, right now. And the kids took this idea and thought, well, why don't we just offer free, we've got access to a vehicle, a truck. We have a company that'll give us free mulch. Why don't we just offer a mulch day? And we just offer these daycares opportunity to have their playgrounds mulch as well as then their side of their houses, which they took us up on. I think 29 out of the 30 that were approached took us up on it. And the kids, without any judgment, they just mulch the yards. As a scientist, I was like, love to know, like, what were the values before the mulching? But that wasn't their point. Their point was solving the problem right now, which is just a brilliant, brilliant idea of how if you give a community partner space, they'll come up with ideas that are at least as, if not significantly more impactful than your own. These interactions inspired us to set up a global network that provides a lot of these resources I just described, which were really Indianapolis specific, to people around the country and ultimately around the world. And so we developed and launched a platform called Map My Environment. www.mapmyenvironment.com, quite literally that simple. Go to it right now, where it not only describes what some of these issues are in the urban environment, what we sometimes call the exposome, what people are exposed to, but also ways to get samples tested. We started off, of course, with soil, because that was our bailiwick, but we've added dust, we've added water, and we've added worms. And now a new addition are birds. No, we don't ask people to collect birds and analyze them, but I'll get to that in just a minute. This launched with a pretty high profile piece with the concept that if we get a tremendous amount of dust samples, then we can not only can provide cheaply and easily the data for the geochemistry, like a heavy metal lead, for example, is very easy for us to do. But we archive those samples and we have them available for any number of additional analyses, including allergens inside the home, the forever chemical, PFAS, antimicrobial resistant genes, and so forth. So we're actually pursuing all of these avenues now. It's just some of them are more expensive, right? So it took a while to settle in. And people sort of most want to know actually the simple stuff, heavy metals and allergens. We've now expanded globally. So IUPUI is a North American hub. We have a total of these just little globes. We have about 1,400 sample results for North America. Our colleagues in Australia have about 5,000, and we have another partnership out of the UK where you can explore. There's various drop-down menus for soil or for dust. We have a number of contaminants, not just lead, but copper, zinc, chromium, for example. And the advantage of having this is it's not a static PDF in some published paper somewhere, right? Or even a static map. This is dynamic. Every week, new data that we upload from our lab analysis gets pulled into this. So it updates weekly. You can zoom in or zoom out. You can put all kinds of layers to it to do more in-depth analysis. We've built this. We've also into this, we built in an app so that you can pretty immediately know what kind of risk factor you might have based on very simple aspects of your home environment. And we just published that last month. We've also been able to use some of this, the sample repository, dust sample repository, to inform us about other indoor exposure, potential indoor exposure issues, including when people started cleaning all their products like maniacs during the COVID shutdown, where everyone would wipe down everything before we truly understand more of the airborne nature of the situation. What that resulted in, based on our analysis, was a doubling of the concentration in indoor dust of these quaternary ammonium compounds, or QACs. These are dangerous compounds. They're in cleaning products, but sealed inside a home and doubling their concentration means they very likely had some negative health effects for residents. And they might not have even elicited the positive health effects against COVID. So it's these kinds of ways to go about doing science, environmental science, that could open up some more avenues for people to not only help communities, but also advance basic or applied science in these kinds of ways. If we focus in on my city of Indianapolis, where we could see, in this case, this is a soil lead concentration for some of our surface samples. You can delineate whether you want it in the samples from near yard, just in the yard, from near the street, or right near the drip line of a house, where they tend to be highest. But we also recognize that we are undersampling some areas, particularly those areas with the highest incidence of poverty, which are in these darker census tracts. So we can start overlaying these maps and targeting these. And that's what we're doing right now with a project funded by HUD, where we've expanded to soil, dust, water, and paint, specifically in homes of kids who have tested lead positive. And so we're trying to augment the current very expensive way that we do lead testing in these homes, which means it takes a long time to get around to reaching the homes, to a cheaper way that actually helps citizens and community members engage a little bit more with their own environment. We then utilize this. A brilliant student who thought, well, are there other biomonitors out there that we can use? And so he and me launched the Bookworms Initiative, and where kids collect worms out in the environment, along with the soil sample. After a rain, they collect earthworms. Kids will do all kinds of gross stuff, including collect worms. They'll pack the worms up in little containers. Right now we're working with some schools, so they're doing this as a school project. We'll analyze that for lead content and report that back to the kids. And then they'll use it for like writing reports about their own environment, making little maps around their schools. And for a certain number of worms, they receive, in partnership with Barnes & Noble bookstore, a certificate for a book. And it ends up that one of the only interventions for a lead-exposed child that we know works is reading. So educational interventions. And that's likely because it starts engaging the mind in a more active way. And even the young mind is still relatively plastic, such that if they have some areas of lead deficits in their brain, well, they can actually build new neurons to work their way around that. And so it's also a mitigation tool. So bookworms, right? They collect a bunch of worms, they get a book out of it, and they also get a mitigation without even, that's a bonus. So it's these kinds of initiatives, I think, that can really embed environmental science in a way that engages a university's personnel and researchers and students into a community where they actually want these services, right? The kits themselves are very simple. Of course, we try to make it simple and fun for the kids. And we'll have to, I'll come back again in a year to tell you when we have a bunch of samples. We only have so far less than 100 samples, maybe 150 as of this week. But we're definitely seeing a relationship between worms, high worm lead and high soil lead, and we'll continue to advance this moving forward. And in just a purely scientific endeavor, we're also using one very curious fact about robins, American robins, which is during certain times of the year, they dine almost exclusively on earthworms. And it ends up that we also have some very talented ornithologists who are looking at environmental determinants of bird health. And so they help us capture birds, they capture birds, sorry. They draw a little bit of blood from them. And now we're analyzing the robins for blood lead in relationship with our worm studies. So we're going from dirt to worms to robins. And we just presented this work last week. It seems extremely promising. And it's a way to link to probably one of the other major citizen science initiatives, probably the biggest one in the globe, which is birders. Birders have always been crazy for doing, counting birds and following them everywhere and logging when they see them and so forth. So if we can get into the birders, I think we're golden in this case. We are well aware that one of the components of the pie for positive outcomes in an engagement is self-efficacy. And this is where we feel like people actually doing their own collecting of samples provides them with a little bit more understanding about their local environment and a few more tools that they can use to apply ways to improve their local environment, whether that's through a simple personal action or that community who petitioned the EPA for another cleanup, right? It provides that kind of self-efficacy. There's many ways to do this, what's called sometimes public science. We published a piece in December about this, but nevertheless, it's I think an exciting and continues to grow, an area that continues to grow. Hopefully I showed you a couple of the ways that I think we've had successes where we've been able to provide public maps of contaminants, as well as simple educational resources about whether the people should be concerned or not. We are publishing what I think is cutting edge science and engaging citizen scientists, and we're training the next group of environmental justice warriors. Before we get too excited, though, it's very clear that the university is not used to this kind of engagement. Even mine, which is pretty forward with this, there's a lot of inadvertent obstacles to getting this done. A lot of inadvertent obstacles to getting young students through programs this way, and obstacles as well to getting faculty promoted, tenured, and funded. So it's very clear that we have to work through a lot of these issues over the next 10, 20 years. And it's young people, young scholars, young academics who I think can have the biggest opportunity to do that. So again, please feel free to visit the website, mapmyenvironment.com. And this is an open invitation, since I won't be there in person, to compile and maybe in discussion groups your questions and send them to me. I'll answer them within the day. gfilippelli@iu.edu. So please do. I look forward to seeing all of those. And if you would like to engage with me on Twitter, that's my handle. Thank you very much for this opportunity.